do academic 9.7 notes. Here we go. I love that. Still, there we go. Here we go. Okay, let me get a drink of water. All right, use a calculator to approximate each logarithm in the 4 decimal places. This is kind of just plug and chug, okay? I got my handy dandy graphing calculator. Okay, to do log of 10, you can do that by hand, by the way, but to do it with your calculator, okay, I hit log 10, and I hit enter. I get 1. Okay, that first answer, the answer to the first problem is 1. Okay, log of 23.1. Okay, I hit log. I need 23.1. I hit enter. 1.3636. Okay. Log of 45,600. Okay. I hit log. I type in 45,600 and I hit enter. 4.658. That's 6590. 4 decimal places, yeah. Yeah, they did that in pre-calc. I don't know why. All right. Log of 0.369. I hit log. I type in 0.369. I hit enter. Negative 0.430. Wait, negative 0.4330. All right. Questions, comments, concerns? What's up, Denai? All right. I'll take it. Yeah, I whipped through those.
No, I couldn't get my notes up.
Yeah, I totally whipped through those. Are you doing okay, too?
Yeah. Couldn't get my notes up. Here's notes on it. Find the notes. Messing around.
Okay. Yeah, so the big idea. I'll watch you. How are you feeling about this? All right, so remember, guys, what's the big idea here? What's the base when there's no base? 10, yeah. Okay. So find the exact value of each logarithm. So now we want to evaluate these by hand, which we can do. Okay, how do we do that? How do we evaluate a logarithm? Yeah, small number to the question mark equals the big number. Okay, by small and big, I mean like the little like font size. Okay, 10 to the what gives me 1,000. Okay, just 3 is the answer. The log goes away when you evaluate it. Okay, this one, 10 to the what gives me 1 over 100. Negative 2. Anyone seeing a pattern yet? Anyone seeing a pattern yet? Okay, there's 3 zeros. There's 3 zeros after the 1 in this number. The answer was 3. Over here, there were 2 zeros in the denominator. The answer was negative 2. See the pattern? Over here, right? 0.001. This is going to be 10 to the what equals 0.001. Be negative 3. Okay, so there's 3 zeros before the 1. Answer is negative 3. So if it's in a decimal form, zeros before give me negative. Zeros after give me positive. It's just however many zeros there are. Okay, 3 zeros after, positive 3. 3 zeros before, that's negative 3. Right here, if it's in fraction form, 2 zeros in the bottom give me negative 2. This one's fun. Okay, how do I deal with a cube root? I probably want to make that what? Yeah, 10 to the 1/3. Okay. What did I just tell you guys? Log base 10 of 10. What happens when the big and small numbers on the log are the same? Cancels. My answer's what? 1/3. Good job. Great job. Oh, identifying natural logarithms. Ah. I know we should do this. I'm going to whip out the definition. All right. This number is perhaps. Yeah, it might be. This number is perhaps the most important number that exists. I'm gonna make that on film. I'll make that claim. This might be the most important number that exists. I'm not joking. All right.
What about pi?
I think it's more important than pi, honestly. That was my hesitation. That was what I was. Yeah. I'm biting the bullet. I'm biting down. I'm doubling down. I'm doubling down. Okay. So this is a number that's called E. Okay, it's called E. Okay, it's called E. My favorite number. It's up there. It's up there. Okay, it's called Euler's number. I think that's probably why we use the word E. It's called Euler's. There's this German mathematician. His name was Euler. He was awesome. Actually, I never met him, but he was really good at math. I don't know how he was as a person. Never hung out with him. Okay. Yeah, he was. Okay. So there's a number called Euler's number. I believe the definition of it, it is defined. I believe it is defined as E equals the limit as n goes to infinity of 1 plus 1 over n raised to the n. I believe that's the definition of it. Let me make sure. Okay, it also has a powered series definition. Let's go to Wolfram Math World. This is perhaps the most important number that exists. If you can do it in your calculator too. One sec. It's up there. All right, the Euler number. Oh, this isn't it. This is this is a different type of Euler number. I need Euler's number. No. Okay, let's go to Wikipedia. I want to know what the rigorous definition. It was discovered in 1683 by Jacob Bernoulli. Oh, he's another big name in mathematics. All right, don't quote me. I think that's the definition. Don't quote me on that. Maybe I should erase it. But it's about, if you look at it on your calculator, I just wasted way too much time. If you look at it on your calculator, okay, you do second. See this E right here above the division symbol? Second E. Put it in, it's about 2.718. Love it. I love it. Okay. It's really special. You probably have to take calculus for me to explain how special it is, okay? But if you see the ln button on your calculator, right? Let's look at the ln. It's right underneath log, okay? Log. You see the ln button? You guys see that? Okay. ln is the same thing as log base e. Okay? So this is just log base e of e. So what's the answer to this? 1, right? Boom. I love it. All right. Let's ln 9.82. Let's do that in our calculator, okay? So ln 9.82. 2.2844. Natural log. It's the greatest number. This next one here. This next one. Okay. ln 132,000. 11.7906. ln 0.015. 4.200. Wait, they wanted 4 decimal places. 1997, sorry. A little rounding error. All right. Questions, comments, concerns? Okay. Maybe I should erase this. Don't quote me on this. I'm pretty sure that's the definition. I gotta see how it's defined. There are things that like numbers are equal to, and then there's like the way that they defined it. Yeah. E. I don't know why E is the letter used, but it's about 2.71. Okay. All right. This next one, we can do these pretty easily, I think. ln of E cubed. Okay. Anyone know off the top of their head what this would be? Yeah, it'd be 3. Because ln is the same as log base E of E. Okay, and when the small and big numbers are the same, okay. So put this in another way, ln and E cancel. Or E to the ln cancels. Okay. ln of, okay, so is this just a 6th root symbol? Is that the answer? No, that's the answer. Okay. What do I do with that 6th root? I change it to an exponent of 1/6, right? Now we have log base E, don't tell me when I wrote it that way, of E to the 1/6. What happens? 1/6. 1/6 of the, there we go. Okay. This last one, or C, that's not the last one. Right, this is log base E of E to the 2.1. Cancel 2.1. This is log base E of 1. Right, nothing cancels, but you can do it by hand pretty simply, right? E to the small number of the question mark equals the big number. I raise E to what number to get 1? All right, questions, comments, concerns?
Yeah.
Now we want to evaluate each logarithm to 4 decimal places. Okay? All right, so 3, let's do this in our head. 3 to the what gives me 6. Just kidding, you can't do that in your head. Okay, we got to use a calculator. Got to use a calc. Okay? All right, one of my seniors figured out a way to put log base 3 of 6 in your calculator. I never have realized that because I just use change of base. Okay. So what do I want to do? How do I put this in my calculator? We're going to use the change. You guys remember the change of base formula? Okay. Well, we're about to. Okay. We can rewrite this as the big number divided by the little number, and then just write log in front of each one. Okay? Common mistake, a lot of people are going to be like, log is 6 divided by 3. That's wrong. Okay? It's not log 2. It's log 6 divided by log 2. You need 2 logs. 2 logs, okay? 0.6309. Okay. Notice when you use the change of base formula, your base of your log can be whatever you want. See, actually, ln 6 divided by ln 3 will give you the exact same thing. It'll give you the exact same thing, okay? 4 decimal points. So if you like the ln button, if you like ln better than logs, would you rather go to ln or have a log? It's a pretty funny concept. I don't know why I brought that stuff on. Okay. Write big number divided by little number, write log in front of each one. Or if you like ln, if you're a big ln fan, write ln in front of each one. Those give you the same answer. Okay, look guys, if you put it in wrong, little mistake. Put the 9 in parentheses. If you forget those parentheses, you'll get the wrong answer. This is wrong. Wrong. Okay, this is wrong. Make sure you put the 9 in parentheses and the 5 in parentheses. So our answer is 1.3652. Okay, this next one, again, big number, 1/3 divided by little number, write log in front of each, 4 ln. 4 ln, that also works. Okay. You guys, make sure you can do this on your own. Log 1 divided by 3. Right parentheses divided by log 6, okay? Make sure both your numbers are in parentheses, please. Take me less time to grade. Negative 0.6131. I also just want you. There you go. Questions, comments, concerns? Alright. Someone do D for me. Tell me what you get. Gotta teach you guys how to do this on your own. Yeah, 5 zeros. Right in here. 4 different places. Yeah, so it would be that fifth. Let's do it. That's 6. Negative 1.5850. Okay. How we feel about this? That bad, huh? Okay. Questions, comments, concerns? All right. You may think that Euler's number is inconsequential, but it is not. Okay? Euler's number shows up everywhere. In finance, in physics. Where else does it show up? In math class? I don't know. Doesn't show up in English. Alright, unless you're like writing a paper on Leonard Euler. It might show up. Okay? Probably shows up in econ, social science, I bet. Okay? Right. Oh, we've seen E before, haven't we? No, we haven't. No, we haven't. So recall this formula for compound interest. Okay, so we learned about compound interest, okay? Compound interest, that's when I put money in an account. It gets compounded every week, or twice a month, or every year, right? There's another kind of interest, okay? There's another kind of interest called continuously compounded interest. Okay? I don't think these word problems are going to be too hard. Continuously compounded interest. That means it's compounded constantly, literally every moment of the day, of every day, it's being compounded. And the constantly compounded. Continuously compounded interest, okay? All right, we're going to use this equation to retire, guys, okay? The formula is A, the final account balance, equals P times E raised to the R times T. Okay? This is account balance. Right? This is my principal. Principal is a fancy word for what? My initial amount. E is Euler's number. It's not a variable. Not a variable. It's a number, right? Pi is not a variable. It's just a fancy symbol. This is the same thing. Not a variable, okay? R is your rate. T is time. T is time in years. Here again, P times E. Good way to remember it is PERT. All right, there used to be a shampoo brand called PERT. Okay, P-E-D-R-T. PERT. A equals PERT. Okay. Dana, this girl named Dana, or guy. This person took $1,400. Put it into a continuously compounded interest account. Okay. Invested it at 8%, 0.08 times 12 for 12 years. Okay. So the principal was equal to 1,400. I was equal to 12. Interest was 8%. Okay, make sure you don't put 8 in, put 0.08, please. Okay. How much is left after 12 years? Let's go over how to put this in our calculator, okay? I think that's going to be the hardest part here. All right. So I'm going to do 14. Let me see. I'm going to do 1,400 times, okay? The E button is right above division. You have to hit second first. So I'm going to hit second E, okay? And that's going to be raised at the exponent button right here. I got my finger on it. To the 12 times 0.08. Now I'll give you the answer. She's got $3,656.38. So find the amount of money Barbara owes. You guys want to try this one on your own, maybe? Let's try that on our own real quick. I gotta teach you guys how to fish. Yeah, so I have a fancy calculator. So my calculator knows that both of these numbers are in the exponent. Your calculator needs parentheses to know that. So you need to put 0.08 and 12 in parentheses. If you're using a GI-83, you need parentheses in your exponent. I went all through high school and college with one. I didn't upgrade to this year. I was kind of retro, you know. All right, let me do it myself real quick. Actually, sorry. $12,000 car loan. E to the 4 times 3.6. I got $15,250.99. 15. So I got it here. Let me write it down. $15,254.99. You guys want me to do it out for you real quick? So we start with our PERT formula. Okay. What's my principal? What's my initial amount? 12,000. Okay. Then a times E, right? That's always the same thing. There's just a button on our calculator for it. What do I put in for R?
0.06.
0.06. And then 4. Okay. And my calculator, I've got it here already, but I can do it again. 12,000 times E. E button's right here, right? Second E to the 4 times 0.06. Alright, I'm supposed to do some homework problems with you guys now. So now what we've got to do here for this next, you guys probably need more space, don't you? Or I guess we got a good margin at the bottom here. Yeah, I've got a good little margin here at the bottom. Let's just use this. What's that? Yeah. I'm going to shrink this on my end. Okay. So we've got to do, I'm supposed to go over some problems with you now, okay? I got to show you guys how to solve for x using log. So if I have an equation like ln 2x equals 7, I need to solve for x, right? I need to solve for x, okay? What does it mean to solve for x? Always, always, always. Get x by itself, right? This would be really nice if it were just 2x equals 7, right? That would be easy, right? So we got to get rid of that ln. How do we get rid of an ln? How do you think we do that? Okay. What? Not quite. We can't do anything with the 2x. It's stuck. It's stuck inside my ln. Right? It's stuck inside of Lorentz norm. No, I'm kidding. Stuck inside of the ln function. Okay. So how do we get rid of the ln? Remember, guys, if I take like 5 and raise it to the log 5, what happens there? Cancels, right? So if I have a log base e, which is what ln is, if I do e to the ln, if I do e to both sides, I got to do both sides. E to the left equals e to the right. What happens to that ln? Boom. 2x equals e to the 7th. Divide by 2. X equals e to the 7th over 2. You can in your calculator. You can just leave it like that, though. If you do it in your calculator, mathematicians would just leave it like that. But e to the 7th divided by 2, 548 about. Okay, again, sorry these aren't as organized. Okay. Log x equals 1.3. How do I get the x out of my log? Divide what? Nope, the x is stuck. X gets stuck inside of log. So what's the base of this log? What's the base of it? What's the small number? 10, right? So what's going to cancel with a log 10? 10. So we do 10 to the left. The base of the log has to be the same as the base of the exponent. 10 to the log equals 10 to the 1.3. Okay, cancel x equals 10 to the 1.3. You can only do that in your calculator. I get about 19.9526. Okay, let's do a bigger one. Let's up the ante a little bit. Okay, ln 3x minus 4 equals 2.3. Okay, you guys want to know this for your quiz. Hint, hint. Okay, I got to get x by itself, right? My x is stuck inside of ln. How do I get it out of ln? What's going to cancel with ln? E. So e raised to everything on the left equals e raised to the 2.3, to whatever's on the right. Does that make sense or no? You've lost. Are we lost?
Does that just get rid of the ln?
Yeah, boom, e and ln cancel. That equals e to the 2.3. Get x by itself. Divide by 3. Divide by 3. We get, this is my answer. You can do that in your calculator. Equals about 4.6581. Okay, you guys feeling okay about this?
Well, you want us to be there.
No, approximate it on your calculator, please. There are some of these in your homework, okay? So basically what happens, so I'll write down a bunch of problems, and I'll just go over this. One of the problems is log x equals 2.3. Another one is ln x equals negative 2.3. Basically all you do, if you see a log, that right, the base of that is technically 10. 10 to the left equals 10 to the right, okay? Boom. The ln e to the left equals e to the right. Boom. Okay? That's how you do those. Questions, comments, concerns? All right. Homework. Here's the homework.